Hello and welcome. In the previous video we created hidden layers. In this video we will create various optimization methods to improve the output of our MNIST digit recognition model. So first let's start with cross-entropy. What is cross-entropy? Cross-entropy is used to identify the difference between the probability distributions. In simple words, it is the difference between actual value and the predicted value. We use a softmax cross-entropy with logits function. It is a TensorFlow function. It compares two outputs, that is the logits or y logits here and y. The y logits is the output or the predicted output, and the y here is labels, that is actual labels or one-hot encoded labels. The reduced mean calculates the mean or the average value of various values generated by the softmax cross-entropy function. Now let us take a look at the optimizer. We use a gradient descent optimizer in this example and a learning rate of 0.005. Usually the learning rate should be between 0.1 and 0.001. You can reduce the learning rate below 0.001, but we should not actually increase the learning rate above 0.1 as the model may not be able to learn properly. Now the train step. Here we use the minimize function to minimize the cross entropy. The cross entropy is actually the loss, so we want to minimize the loss. The gradient descent optimizer will help us to minimize the loss. Now let us take a look at the correct prediction. The correct prediction is used to find which prediction was correct and which prediction was not correct. So we have two functions here to do that, the argmax and the equal. What argmax does is it picks up the index of the maximum value in an array. The output here will be an array of probabilities. So it will select the index of the value with highest probability. Y here is the one-hot encoded vector. So argmax will get the index where the value is 1. Then it will compare these two values using the equal function. The accuracy will calculate the accuracy. The cast function will convert the correct prediction, the output here correct prediction, it will convert it to a float data type, and similarly it will try to get the mean or the average value. So now let us just execute this part of code. So we wrote the optimization functions which will help us improve the performance of our model, and the accuracy which will help us identify if a model is performing properly or not. So I hope you like the video. Please click on the like button and subscribe to my channel. Thanks a lot for watching.